Okay, Captain Larry. So what we're going to do now is I'm going to just try to show you the basics of using a Hickok tube tester. This one happens to be a model 533. 533s and 535s have this form factor. They're fairly common. And then the newer one is more rectangular, and that's a 600 to 600A. Works exactly the same way. It's really the same circuit. It's just a different package. The military ones I've never used, but probably very similar. First thing you want to do, now I've got a floor heater here, and I've turned it off. Because the first thing you do, after you let this thing warm up a little bit, is set your line voltage. On the far left here, P7 is the line adjust button. You push it, and the needle is supposed to line up with this little indicator line in the middle of the meter. Over here on the left-hand side, there's a line adjust pot, and as you turn that, you're compensating for changes in the line voltage. So to make sure that your calibration is correct, you just set this thing up at the beginning. And I've turned off my floor heater because every time that kicks in, the line voltage will drop a little bit and the needle will go a little bit and the calibration will change just a little bit. So that's the first thing. Next thing is decide which tube you're going to test. In this case, I'm going to use a 6C4 just because it's handy. And I'll go over here to my chart. That's the wrong one. I didn't explain that there are a variety of tube testing charts for these things, and they changed over time as older tube types became obsolete. They dropped off the chart. Newer type tubes were added as time went by, and it was important for the serviceman to have data to test those newer types, and so they were constantly coming out with newer charts. So this one, they usually are on a roller in here, and you can roll them back and forth, but because I've got several, they're not inside the machine. So here's a couple of roll charts. Here's a roll chart that's been cut up and pasted onto pages, and it was in a little ring binder. So I have 3 of them because it just covers a broad range of tubes. Okay, so we're going to do a 6C4 and get on the handy dandy little chart here. It's alphanumeric, and you can see it's going 6CA4, 6CA5, 6CD, da 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 da. So we're going to find 6C4 in here, and then we're going to set up the machine. And this machine, luckily, it's labeled right across here telling you what each one of these function switches does. So the first 2 are the filaments, and it says we're going to set the filament voltage. So we're going to go over here to the filament voltage switch, and we're going to set it to 6.3. Down here in the lower right hand corner is a switch that's labeled life test. Which this does is actually reduces the filament voltage a little bit. So you want to make sure that's in normal. You want to make sure you set your filament voltage correctly. These tubes are now expensive. Some of them are hard to get. You don't want to ruin a tube just because you set your tube tester up wrong because you weren't being careful. So we get 6.3. Now we're going to go over here and assign the filament voltage to the right pins. In this case, it's JR, which is one of the very common settings. So we're going to set that to J, and we're going to set that to R. And that makes sure that the filament voltage shows up on the right pins on the socket. And next we're going to go and set these 1, 2, 3, 4, 5 switches, which are labeled, luckily, grid, plate, screen, cathode, and suppressor. And what this is going to do, in this case we're looking at a 7-pin miniature socket, this is going to assign the grid connection to the proper pin. In this case, it's pin 6, so grid 6. So we're going right across the line here, and they're not labeled this way, but you just read them right to left. So it's going to go 1, 2, 3, 4, 5. So the first one is 6. The next one is 3. It happens to be the plate. You're not going to be thinking about what these are. You're just going to be thinking about what the numbers are. 63070. So 6, 3, 0, 7, 0. Okay, we got the screen is 0 and suppressor is 0. This is a triode tube, so those elements don't exist in the tube. So we got that set up. We're going to go back and double check. 6.3 JR 63070. 63070. Next, we're going to set the bias. The bias is 25. Now on this list, way back in the beginning of the book, if you read the instruction book, it's going to tell you what these things are, but it's bias and English, which is the load on the tube, and then they'll tell you which test button to push. It'll be P4, it almost always is. The other thing you have to do is set the range for the transconductance. It says Micro Mhos, and that's the scale that you're reading transconductance in. So this one is going to read 2200. So we're going to go for 3000 full scale. You get a choice of 3000, 6000, or 15,000. I very seldom ever seen a tube that goes that high. So now we're going to double check. Let's see, we got to set the English 75. So now just double checking again. We got 6.3 JR 63070. We got the bias set at 25. We got the English set at 75. We've set the range on the transconductance meter in Micro Mhos to 3000 full scale because it's going to be 2200. It's a single element tube. Okay, found the tube. 6C4. So the next thing we're going to do is put the tube in the right socket. And I haven't sprayed this, so I'm going to give it a little spritz of deoxit with these used tubes. Is a very good idea to make sure that your tube pins are clean. It's hard on your doggone tube tester if your tubes are crummy. If I have a tube that has corroded pins, I won't use it. I won't even put it in my tube tester because tube testers are expensive. They're not easy to repair, and you just don't want to screw it up. So after you've put that tube in there, another reason is you want to clean the tube is that you can see inside it. And if you've got an old tube tester like I do, I've got at least one with a Baki socket. I can see the filament right there. It's a very dim filament in a tube like this, but it's there. So once that filament has had a chance to warm up slightly, you want to check the line voltage again. And this is dropped down just a hair. So I'm going to reset it. Now, what are we going to do next? Are we going to test it for transconductance? We can. But there's another couple of tests that you can do, and you should do at this point, and that's to test it for shorts. So this short switch over here is in the tube test position, but I'm going to turn it backwards and watch this bulb here which says shorts. And it's not unusual for this to flash slightly as you change the switch, but it should not illuminate. If it stayed illuminated, we'd know that there was a short between one of the tube elements, and we'd have a bad tube. And at that point, you should really discard that tube. Make double sure. You can clunk it with your finger and stuff, but occasionally you'll get a false reading on the shorts, but generally not. So we've done that part. Now, in our handy-dandy little book here, it's going to tell us which of these tube testing buttons we should use. And they are not all the same. They're for different purposes. And, we're not testing a diode. We're not testing a gas rectifier. So we want to make sure we use the right test button so we don't wreck the tube. So it tells us P4, which is the one that it almost always is, and it's marked GM for transconductance. So let's take a look. Bingo. 2250. 2150. The 22 is a new tube, so that's extremely good. I'm just holding the button down here to see if it's going to change, and it's maybe creeping up slightly. Now I'm going to give it the life test, and that's going to reduce the filament voltage a little bit. I don't know if you can see this meter, but it is holding extremely steady. It might have dropped down 50, but a bad tube, it'll just go like that. So we'll run it back up there and let the filament warm back up to full temperature again. So now we've got 2150 out of 2200. Now it's up to 2200. So this is essentially testing as a new tube with extremely good filament emission. When we did the life test, it didn't drop down hardly at all. Now there's one more test that we can do, and that's to test it for gas. And so what we do then is push the P4 test button and run the bias down until this is back down to about 100, the first big notch on the meter. Now we push the gas button, and it shouldn't come up higher than we set it at. Push the gas button and it still says 100, and that's good. So let's go back to the bias to 25. So what we've determined now is we have a tube that's giving the proper amount of amplification. Oops, didn't set the bias right. You set the bias wrong, and this amplification factor will go all over the map. So you want to get the bias set quite closely. So here we are. We're still 2200. So we've got the amplification factor of a new tube. We've got filament emission that's like a new tube because the amplification factor isn't going down when we do the life test. There's no shorts and there's no gas. So this tube, I'm going to make a note on this, and this is something I do all the time, is write on the tube. In this case, this is 100%. There's 2 or 3 ways you can do this marking. The transconductance here was 2200, and it marked 2200. So if it was like 1900, it measured, and the new was 22, I'd write 19/22, and then I'd calculate out what percentage that is. It's about it's down about 300. So that's 300 out of 22. I think it's about, that would be 87% or something. I have to figure it out. But anyway, this is a new tube, and the other thing I can do, and often will do, is just write new in quotes. If I put the quotes on there, I know that it's a used tube, but it's tested new. So this is wonderful. You can't ask to find a nicer tube like this in a radio. You're pulling a tube out of an old radio. You don't know how good it's going to be. And here it is, and it's testing new. So here's 6C4, and I'm going to write 100%. And 2200, I'm going to note the GM here. And for filament emission, I'm going to write new. So that's the third audio tube in there. This is the tube that after the clipper, this drives the drivers basically, and so that's an excellent tube. You can't want anything better than that. So that's something to check off the list. So now what we're going to do, since this is both a tutorial on how to use the Hickok tube tester, and also what we're doing for the overhaul of this this Valiant, is I've got my list. I've tested the tube. I've written down the percentage of new, and I've written down the actual transconductance and the filament emission. So now I can look later, you know, look back in this thing 5 years from now, or if this transmitter goes to somebody, I can show them exactly what they're getting. And I know. And one of the reasons that I'm going into so much detail with these tubes is the modulator tubes, a pair of 6146s, need to be well matched. They're push-pull audio tubes. They need to have nearly identical amplification factor, transconductance, and they need to have very high filament emission. So what I want to do, I've got 5 tubes of the same type. I'm going to go in there and list the transconductance for all 5 tubes and the filament emission, and match up 2 tubes to use in the modulator that are the best matched that I can find. I don't want one strong one and one weak one. Or I don't want any. I also don't want a pair that seems to have very high amplification factor but has poor emission, because they're gonna sag under audio peaks and distort, and that's not what you want. So that's what we're doing here, and this just repeats and repeats. Let's look at another tube with 2 sections. Let's look at a 12AU7 or a 12AX7, because they're just a little different, and then we'll look at a rectifier. So I'm rolling my tube chart back here. I'll put this up here we can see it. I'm just rolling my tube chart back until I get to the right section. We're down in the 5-number commercial and military tubes here, but we'll roll it all the way back just for because it's so entertaining to watch me roll a damn tube chart. I mean, isn't it? Yeah, I didn't think so. Okay, anyway, somewhere in here, oops, I'm at the wrong end of the tube chart. Alright, you can watch me make mistakes, why not? So let's take our book and go back here to the section where it says 12, and 12A, B, A, C, A, L, A, 12AU. So, let's set this up now. So now we've gone from a 7-pin tube to a 9-pin miniature, and we've gone from a single section triode to a dual triode, a 2-element tube with 12-volt filaments and 6-volt instead of 6-volt filaments. So this is going to require a completely different setup, and of course every tube requires a completely different setup. So let's just go the procedure again. And you want to make sure, since there's all of these things that are very close together, that when you're reading across this chart, you don't inadvertently slip down and start using the numbers for a different tube. So the first thing we're going to do is set our filament voltage, 12.6. So we'll go from 6.3 to 12.6. Now we're going to set up the filaments over here, and we're going to go to EV, which is also another extremely common setting. Most of the tubes that you see are either going to be JR or EV. Not always, but those are very common settings for 6 and 12-pin tubes. Okay, we got 12.6. We got this set up for EV, for a 12-pin tube. Now we're going to go down the line here with these 5 controls. 3, 5, 6, 7, 2. 3, 5, 6, 7, 2. Now, this is a 2-section tube, and if you look on the chart, I don't know if you can read it here or not, you see 12AU7, you can see these little brackets over here to tell you that there's 2 settings for the 12AU7, and the first one is going to be for the first triode, and the second one is going to be for the second triode. Over here on the other side in the notes it says triode number 1, triode number 2. So let's just go across and do it. Oh, good. This is interesting. See, I've made a mistake. Don't you love it? I've used the 12AU6 settings, and if I had done this, I'd have blown the shit out of this poor tube. So let's go back and do it right. 76080. So here's the grid on pin 7, but I had it set for pin 3. 6. I had the plate set on pin 5 instead of pin 6, so that would have just really screwed things up. 76080. Okay, here's the 2 zeros, no screen, no suppressor, because they're 2 trios in one envelope. They don't have those. 76080. 76080. Do not screw this up. Bias 24. So we're going to set this over here to 24. And then the English. I didn't show you how to use the English setting last time. I'll show you this time. It's again at 75. And the test is going to be P4. And again, it's going to have a transconductance of 2200. So we're going to keep this 3000 full-scale Micro Mhos setting. So we're good there. Now, double check the filament voltage and the pin settings so we don't screw up. 12AU7. I'm going to shoot the tube pins here because, again, this is a used tube that's pulled out of this transmitter, and I just want it to be nice and clean. So, want to look in there and make sure the filaments are working. I've got one kind of dodgy socket in here, and I think it's a 12-pin one. And so I want to make sure my filaments are lit. Go back and check my line adjustment. The line adjustment has dropped again under this different load for different filament. This is something you'll see if you put in a tube with a heavy filament in it, like a rectifier, one of these 6146s. It can cause the line meter adjustment to go down quite a bit. So that's you want to check this every time before you start checking your tubes. So we're all set there. Tube's getting warm. Let's do the short test. So we're going to just run it along here and look and see. Not seeing the short light stay illuminated, so we're good for shorts. The next thing we're going to do is P4, and we're just going to test it, and we're going to see. And there we got 15, 16, 17, 18, 1900. Now sometimes, oops, see how I jiggled that tube and that reading went up? That's a dodgy tube socket. Let's check the line adjust again, and we're up there with a GM of 20, almost 2700, 2650. That's a pretty frisky little tube right there. Let's do the life test on it, and we'll just watch that needle, give it a minute while the filament cools off. And it's dropped off, 100 or so. Now it's down to 2600, and it was at 2750. And actually crawling back up again. So there we go, and you can see it go back up. $2,600. 20. Okay, so now let's do the gas test on this tube. When you see, it's not too unusual to get a tube, especially a new tube, that will read even higher than the book says. But if it's quite high, what you want to do is make sure that you do the gas test on it. So here we are. We're going to crank this down, crank the bias down until it reads 100. Then we're going to do the gas test. And it shouldn't really go up any more than what you set it at. It might go up 50, but it shouldn't go up much. And this is sitting right on the money, right where it should be. So now let's go back to the proper bias setting of 24. And there we are, 2650. Okay. So, now we got a 2-element tube. What are we going to do? So here's a 12AU7 on the GM. I'm just going to divide the box in half here, because there's 2 elements to the tube. And the first one, I'm going to write 27 over 22. And the filament emission test is very good. And the percentage is, 100 plus. So, okay, now let's go and test the other section of this tube. Now, one of the 12AU7s in this thing is used as a driver for the push-pull modulators. So, each one of the triodes needs to be pretty well matched with the other section if you want to keep the distortion down and have it work right. So what we're going to do now is go back and change this setting so that we can test the other section of the tube. The filaments are going to stay the same, the bias and the English are going to stay the same, but what's going to change are the designations for the grid, the plate, and the cathode. So let's go through and change that to 21030. 21030. Now, if you test tubes a lot and you test similar types a lot, some of these settings are going to get to be pretty familiar, and 12AU7, 12AX7 is one of those tubes. Okay, 21030. Everything else is the same. We've got the bias set, nothing's changed. You don't want to change these other settings because you're trying to check the match of the tube. Okay, this came up as 2575, not quite 26, but 2575. And that's good. If the other section of the tube isn't, if the tube's gassy, it's going to show up on both sides, so you don't have to worry about that. We can do the short test for this one as well, because it's a different section of the tube, and the short test is fine there. The filament life is not going to be any different because it's the same filaments for both tubes. Doing the same thing, it's dropping, barely dropping 50. So we'll just check our line test one more time, make sure our calibration is good. So there we are, we call it 2550. And the other section, I called it 2200, but I was, no, 2700, and this one is 25.5 over 22. So the difference between those is like 150 out of 2200. It's okay. This video is actually going to be edited together out of 3 parts because I managed to make a considerable number of stupid mistakes yesterday, including forgetting to plug in the camera. So in the middle of my explanation of doing the 2-section 12AU7, the battery died. So I kept talking for another hour for no reason. So what we're doing is making a third section here. So while I was talking away and then not recording, I measured the other section of that 12AU7, and it came out to, I think, 2550 over 22, and the other section was 27 over 22. Then I had another 12AU7, and I checked it, and it came out 2350 over 22 and 23 over 22 with very good filament emission. So that's an extremely well-matched tube between the two sections. And so I made a mark on it to use it as the audio driver, and the other less balanced tube I use as the keyer tube, where it won't matter at all. So missing in that video was my testing of 5 6146s, and the setup procedure for that is essentially the same as for any of the other tubes that we've done. The only difference is that the 6146 has a plate cap. So you plug this little cable over into the banana jack where it says plate and hook it on the top and proceed as normal. What I did find with the 6146s is that they all seem to cause the shorts lamp to glow on 2 or 3 sections, and I believe that that is an artifact just due to this tester and that type of tube, and I don't believe there's anything wrong with all 5 of those tubes. So as I said, occasionally you'll get a false reading there, and if you're unsure, get a new tube and put it in there, a known good new tube, and put it in there and check it. And the same thing is true if you get really wild transconductance readings. Sometimes, you know, on the various charts, particularly for 6146s, I've seen different kinds of transconductance readings depending on the chart. So it behooves you, if there's any uncertainty, to get a new tube and to check the calibration of your machine, and perhaps make a note on your chart that you've tested a new tube and gotten a particular transconductance reading on it. Okay, what I'm going to do now is test a peculiar type of tube, which is a Mercury Vapour rectifier, and these are peculiar in a lot of ways. So this has a fairly heavy current draw for the filament, and that will cause this fuse lamp to light. Let's check the line voltage here. That's way up, so we'll run that down. That'll help. The point of this fuse bulb here is to show you if a tube is drawing a very high filament current, and the bulb itself will get brighter and brighter as the current draw goes up, and the bulb will actually burn out before it'll allow the transformer in here to fail. So that's an indicator and a protection as well. These Mercury Vapour tubes, this is an 866A. This one happens to have a small envelope. Often they have a much bigger envelope. Are a special case when it comes to tube testing. They have mercury inside, which has to heat up and vaporize to make the tube work. And when the tube hasn't been used for a long time, you may want to you may even see liquid mercury rolling around in the bottom of the tube. If you see liquid mercury rolling around the bottom of the tube, that tube might well need to cook with the filament on for half an hour or an hour before it's safe to apply any high voltage to it. These, you can see the mercury is clouding up on the envelope. The envelope is cold. It's 60 degrees or so in the shop right now. So the envelope is cold. I did test these tubes yesterday, and I did vaporize the mercury in them, but you can still see that it's vaporizing and condensing on the envelope. And as this thing heats up, you'll actually see this condensed mercury kind of burn off, and it goes into vapor, and this will clear up, and you're starting to see it happen now. So this is going to sit here for at least 5 minutes while the mercury vaporizes. So setting this up is somewhat different, and the testing is somewhat different for any kind of rectifier. You don't measure transconductance on these because they don't amplify, so all your testing is done in the English mode, and the bias is always to 0, and you have to set the English, which is the load, according to the book. And I'll look in the chart here and see if I've screwed it up. Bias 0, English 62. So there we go. When you measure a rectifier, you're just going to get a good bad. That's all you're going to get. And if it's up, it says diode's okay, so any place past this mark here, it's going to be okay. Really, the only thing goes wrong with these things is that the filaments either burn out or the filaments get very weak, and then they won't work anymore. Maybe you can see here that this line of the mercury is creeping up as the mercury vaporizes, and it quits condensing on the envelope as the envelope heats up, and eventually this cloudiness and this mark will really go away. This tube tester does probably not put very much voltage on this tube, and so it's not likely that this tube could arc over. But in a transmitter where there may be 1,000 volts or more on that rectifier, if you don't warm the rectifier up properly, and the thing will arc over inside the tube, and it can actually destroy your transformer. So you really want to be careful with these tubes. In general, I don't use 866As. There is a Xenon Gas Rectifier, which is a direct replacement. That's a 3B28, and it does not contain any mercury. It will not flash over. They last almost forever, and unlike these things, I don't think they produce X-rays when they're working. So these are not the tube of choice. I'm going to probably use these because I have them and the tubes are okay, at least to be testing the transmitter, but I'm going to dig around in my stash and see if I've got some 3B28s left, and if I don't, I'm going to buy some. Every high power transmitter that I use that uses these 866s, the first thing I do is substitute the 3B28. It's a direct plug-in replacement, and they don't generate radio noise, they won't arc over, they don't require warm-up like these things do. They're just a superior tube in every way you can think about. So anyway, the testing drill for these, you notice that all these things are set to 0, and that's the way it's going to be for any rectifier. We're not going to use this P4, the transconductance test button. We're going to look in the chart, and the chart will tell us to use P3, which says rectifier. There's 2 or 3 different rectifier buttons here depending on which tube you're using, and this chart also reminds us to connect the cap, the plate cap. If you don't connect the plate cap, it isn't going to work. And this is high voltage here. I don't know how high it is in this tube tester. Probably not more than a couple hundred volts. But you still, you don't want to do this and touch that in the chassis. You don't want to touch that while you're testing it because there's high voltage there. Okay, this thing is, you can still see some clouding back in the shoulder and the top of the tube here. And because this thing has got low voltage on it, I probably can go ahead and test it now, but I'm going to wait just a little bit to be on the safe side. Again, you set the load, you set the English, you put this in the English position, which is the good bad reading on the meter, and that's all you're going to get. You get a relative look at the amplification in a tube that amplifies. On this one, you're just going to get a look at how well it conducts. So I'm going to go ahead and test this now. I'll push P3, the rectifier test button, and it goes up in the green. I'm going to turn the light off here for a minute so you can see the color of the gas in there. When this is working, you can see that this is turning blue, and that's the ionized mercury vapor in the tube. So when they're working and there's high voltage applied to the tube, they're going to glow that blue color. And if you happen to be working on a transmitter with the case off, and sometimes you have to do, well, it's fairly dangerous, and you see that tube is blue, you know there's high voltage on there, and you don't want to be in there. So anyway, that's the story of that. This is a fairly heavy filament, and it will require line adjustment. And once the tube is good and warm, you want to double check that. But again, there's nothing but good bad on this, and that's all there is for rectifiers. Both these tubes have a loose base. And so I've written on the tube loose space to remind myself not to grab this tube by the envelope and pull it out of the socket. I probably will try to repair them with some super glue or some kind of a glue, I'm not sure what. So, testing the voltage regulator tubes, the OC3s, is very similar to this testing procedure. And again, you're going to see the tube glow purple on the top. Let's see, find one of those things. Here's one. And this will glow blue or purple here when it's ionizing, when the plate voltage is applied to it, if it's working. And again, you just get a good bad reading in that, and that's all there is to it. I think we've done everything that's really important to do here. I didn't explain it on any of these other tubes, but the use of this English thing, this is a relative good bad kind of a reading. It is a transconductance reading, just like the other ones is, but it's just really only calibrated in good bad. You're not going to copy any numbers off it. It's kind of like what you had in a drugstore tube tester, and they gave you good bad, and with most tubes, you'll still set the bias. That's very important, and you'll set the English, which is the tube load, and you'll get a good bad reading. And it's relative, you know. You'll get tubes that are weak, and they'll go down and down and down, or they'll be in the question mark range, or they'll be in the red range. Replace. And usually, what that is because the filament has worn out and the filament emission is low. But sometimes it can be because you know, the screen or the grid has been damaged in the tube, and it's not working properly that way. So I think that pretty much winds up what we need to do here. We've covered the fact that there are different charts, and you want to have a chart that matches your machine. There's one other thing that we haven't talked about, and it's kind of an advanced use of a machine. But if you have a tube that does not appear in your tube chart, and you own a tube manual, particularly you know, an RCA, Sylvania, GE type tube manual where they show you the transconductance and tubes of the stuff, you can use that. You can use the base diagram to set up these switches to according to the base diagram of the tube, and find out which pins the filaments are on, set the filament voltage the way it should be, and then what you're really doing is you're making your own entry in a tube chart for a tube you don't have values on. You need to know what the proper transconductance for a new tube is, and it's a good idea to get a new one and do this. And then what you're going to do is basically set the bias to 0 and put the tube in there and push the transconductance test button and adjust the bias until the needle here agrees with what the reading is supposed to be for a new tube. And you'll use that as a way to create a chart listing for a tube that you don't have, and then you can test used tubes of that type against the reading that you got for a new tube, a brand new tube. And if you get 2 or 3 brand new tubes, that's even better. But that's a way around testing a tube that doesn't appear in any roll chart that you can get your hands on. And I have done that in the past, and it does work. And so anyway, it's you know, it's a little experimental. You really need to know your way around your tube tester and tube charts and tube specifications in the manual. But if you understand those things and can get your tube tester set up properly, then you can accomplish that. If you have any confusion about how to set these up, find a tube that has the same base diagram. And they you know, like there's a base diagram that says CK. So you look at a tube with CK and you find a tube that's in the chart that you know has that base, and you set grid plate screen cathode suppressor up properly for that base diagram, so there's no confusion about that. And do the same with the filaments. Make sure you have the filament voltage set correctly, and then from your tube chart find out what your transconductance is supposed to be, set your meter up in the right range, and then put the tube in and do the test and run the bias up until you get a reading on the meter that's the same as what the transconductance is supposed to be for that new tube. And there you go. You write that in your chart, and you can refer to it later. Let's see, where was the tube that I was testing? I think it's basically the same tube as an 811A transmitter tube, but it had a different filament voltage and a little different amplification factor. I think it was a TZ40 or an 809, something like that. And there wasn't a listing in the book, but I could do the cross-referencing in a tube chart and figure out what the gain of the tube is supposed to be. And so I was able to use the basic settings for an 811A, change the filament voltage, and figure out what the setting of the bias should be so I was getting a proper reading. And you know, I had a new one, I put it in there and checked it. And then I was able to check used tubes of that type, even though they didn't appear in the book. So, okay, I think that's going to wind up this video on how to use the Hickok. If you're using one of the newer 600As, it's going to work exactly the same as this does. It may have some different types of tube sockets. It might have a tube socket for a compactron or a new Vistor or some other kind of strange tube, but it's still going to work and operate just the same. Thanks for looking. W6WUH.